Hello, so we have Physics 2, 16.46 problem. Question is, what fraction of the electrons are lost during the copper wires? So the mass of the copper wire is 3 grams. They give us the charge of 32 nanocoulombs. And you find out that the atomic weight of copper is 63.55 grams per mole. So we must find the actual moles of there. So we'll take the mass divided by our moles, so we get 3 divided by 63.55. You get 0.0472 moles. Now, because of that, we're trying to find how many true atoms are in there to help try to find the electrons lost. So we'll take 0.0472 moles times 6.02 times 10 to the 23 atoms per mole. You get 0.224 times 10 to the 23rd atoms. So because copper, there's 3 grams of copper, so it has 8.246 times 10 to the 23rd electrons. And so you do your conversions to get 32 nanocoulombs into 32 into coulombs, so you get 32 times 10 to the negative 6 coulombs. Now we're trying to find the number of true electrons in there, so we'll take our atoms times number of electrons, so you take 32 times 10 to the negative 6 coulombs times 1.6 times 10 to the negative 19 electrons, and you get 2 times 10 to the 14th electrons. And now we must find the electrons lost here, so I have 2 times 10 to the 14 electrons divided by 8.246 times 10 to the 23rd atoms there, and you get 2.425 times 10 to the negative 6 electrons lost for that. Now on to 16.47, where we must find the magnitude of the electric charge on Earth. So they give us that the force they have is 150 nanocoulombs. So first we must find the mass of it, and we will do that by using the formula 4/3 pi r q times d. D in this case being density of 1,000. So I have mass of 4/3 times pi times 0.000018 to the third power times 1,000. You get 2.4 times 10 to the negative 11. Now you must use this equation. EQ equals mg, which stands for E is electric force. They give that as 150. Q is the charge. We're looking for the charge on this. M is mass and G is gravity. So you have 150 Q equals 2.4 times 10 to the negative 11 times 9.81. Since we're using metric on this. So you multiply the gravity times mass and then divide by your E there. You can get Q to be 1.6 times 10 to the negative 12. And we must find the electrons on this. So the electron charge is 1.602 times 10 to the negative 19. So we'll take 1.6 times 10 to the negative 12 divided by 1.602 times 10 to the negative 19. And that equals 1. Well, it actually equals, it's 9.9 times 10 to the 9th. Or to the 6th, I'm sorry about that. But you round up and you get 1 times 10 to the 7th. And that is our charge on Earth at that time. And finally, for the last one, 17.77. At what points on the line are the electric field and the electric potential 0? So we start off with our two charges, 3.4 nanocoulombs and negative 2.6 nanocoulombs. And then our distance between those is 2.5 centimeters. So we'll have 2.5 plus x divided by d minus 1 equals the radical of 3.4 divided by 2.6. And when doing this, you have 2.5 over d plus 1 equals 1.14 over 3. You minus that 1 later on, so you have 2.5 over d equals 0.143. Multiply the d to the other side, and then divide 0.143 from 2.5, and you'll get d equals 17.48 centimeters. That's for your electric field and your electric potential. you would start off with k times negative 2.6 divided by y plus k times 3.4 divided by 2.5 plus 1 equals 0 on that. You get 2 plus 5 over y plus 1 equals 1.307. Minus that 1, you get 2.5 over y equals 0.307. And now, since this is the same thing as before, you're going to multiply the y to the other side and divide 2.5 by 0.307. And you get y equals 8.14 centimeters. And because of that, later you'll have 2.5 minus y again divided by y equals 3.7 over 2.5, and then 2.5 divided by y equals 2.48, and you divide those, and you get y equals 1.008 centimeters for that. Thank you.